Welcome back, dear students. So, as most of the important topics have been covered in the earlier videos on tangents and normal, today's class will be much easier for you to understand. Okay, so without further delay, let's see the first question for the day. So, question says find the point on the curve y equals to 3x square minus 2x plus 1 at which the slope of the tangent is 4. So there's a curve given to you, okay, and okay, so let me first note down what are the things that are given to us. The given curve is so it is y equals to 3x square minus 2x plus 1, isn't it? Now since they are talking about slope of the tangent, let's find the derivative of this. Okay, so differentiating both sides with respect to x, so you get dy by dx is equal to, so this becomes, okay, so derivative of x square is 2x, so 2x into 3 is 6x minus you get 2 out here. Okay, so this is the derivative. Okay, now question is asking you the point at which slope of the tangent is 4. Okay, so consider the point to be x1 y1. Okay, so if I take the required point to be x1 y1, we need to find the slope, that is dy by dx, at this point. Okay, so therefore your slope of the tangent, okay, so therefore the slope of the tangent, that is dy by dx at x1 y1. Let's see how much do we get. Okay, so in place of x I'm going to write x1, so we have here, this becomes 6x1 minus 2. We don't have y, so that's why we will have our slope of the tangent to be this much. Okay, so according to question, slope of the tangent is given to be 4, isn't it? So that's why we must have 6x1 minus 2 equals to the slope, that is 4. Okay, so bring this 2 out there, so you get 6x1 equals to 8, and bring this x1, bring this 6 to the denominator, you get 8 by 6, and when you do the cancellation you get 4 by 3. So I got the value of x, that x1, that is I got this one. Now I want to find y1. How to find y1? So for that I am going to use this particular equation, because you know that x1 and y1 lies on this, so that's why x1 y1 must satisfy this equation. It means that in place of y I can write y1, and in place of x I can write x1. Okay, so call this as equation number 1. So from 1, okay, so from 1 we have, so we can write y1 is equal to how much? 3x1 square minus 2x1 plus 1. Okay, now let's substitute the value of x1. x1 is 4 by 3, right? So we have 3 into x1 square, so this is x1 is 4 by 3, so x1 square becomes 4 by 3 into 4 by 3, minus you have 2 into x1 is 4 by 3, plus you have 1. Okay, now your job is to simplify this. So first let's cancel these two, so this becomes 16 by 3 minus this is 4 2s are 8, this is 8 by 3, plus you have 1. Okay, now find the LCM, so LCM is 3, so 16 minus 8 plus 3, that's what you're going to get. So 16 minus 8 is 8, 8 plus 3 is 11, so what you're going to get is 11 by 3. So you got the value of y1 also. So therefore the required point, okay, so therefore the required point on the curve 1, on the curve 1 is, so the required curve is x1 is 4 by 3, comma y1 is 11 by 3. So this is how we need to do this kind of sum, right? So we have some more problems of similar kind, we'll see that later. So you may pause the video and note down your solution. Let's move to next question. So next question says, at what point on the curve does the tangent make an angle of 45 degree with x-axis? So this sentence plays major role out here. Okay, so since given is, since the tangent makes an angle 45 degree with x-axis. Now what does this mean? It means that, okay, so suppose let's say that this is the tangent, okay, and this is your x-axis. So this angle is given to you 45 degree. So if this line makes 45 degree angle with the x-axis, then we can find its slope. Okay, and you know from class 11, slope m is given as tan theta, where theta is given to be 45 degree. So that's the use of this particular sentence. Okay, so let me continue this. So therefore, slope of the tangent will be equals to how much? It will be equals to tan 45 degree. Now the value of tan 45 degree is 1. All of you know this. Okay, now the given curve is this one. Okay, the given curve is y equals to x square. Now from here onwards it is similar to the earlier problem. Okay, so you can call this as equation number 1, and you can do the needful, isn't it? So I'm leaving this work for you to complete by yourself. Okay, so you may pause the video and note down your solution till here. Let's move to next question now. Okay, so the next question says, find the slope of the normal. So remember, this is not the tangent, this time this is normal to the curve. Okay, so this is given in parametric form. Okay, so we have already seen one problem of parametric form, if you remember. Okay, so the given curve is, the given parametric curve is x equals to a cos cube theta, call this as equation number 1, and another is y equals to a sine cube theta, call this as equation number 2. Remember, you need to find slope of the normal. Okay, so first let's find what's dy by dx. So for that, I need to differentiate both x and y with respect to theta, because theta is a parameter out here. Okay, so differentiating 1 and 2 with respect to theta. So let's see how much do we get. So we get dx by d theta here. So dx by d theta, so it's gonna be a into, so this is for power, you get 3 cos square theta, 3 cos square theta, into, for cos theta you are going to get minus sine theta. Simple. Okay, so let's rearrange this. So you get minus 3a sine theta cos square theta. So this is your dx by d theta. Okay, now differentiate number 2 with respect to theta. So you're going to get a into, now for power you get 3 sine square theta, into, for sine theta you're going to get cos theta. Differentiation of derivative of sine theta is cos theta. Now how much is this? So this is 3a sine square theta cos theta. Okay, so I got my dx by d theta and dy by d theta, but I want to find dy by dx, isn't it? So therefore your dy by dx, as per the formula, it is dy by d theta by dx by d theta. This is the formula, please remember this. So dy by d theta is 3a sine square theta cos theta divided by dx by d theta is minus 3a sine theta cos square theta. Okay, so 3a and 3a gets cancelled, sine theta and sine square theta, they gets cancelled, cos theta and cos square theta, they also gets cancelled. So this is minus, it is sine theta by cos theta, that is tan theta. So this is your dy by dx at Okay, this is your dy by dx. Okay, now let's find the slope of the tangent. Okay, so we will find dy by dx at theta equals to pi by 4. Okay, oh sorry, by the way, question is asking you to find a slope of the normal. So therefore we have dy by dx at theta equals to pi by 4. So this is going to be equals to minus tan theta. Theta, in place of theta I have to write pi by 4. So pi by 4 is 45 degrees, so tan 45 degrees 1. So that's why it is minus 1. Okay, so therefore slope of the normal, that's what the question is asking you to find. So slope of the normal will be, now it is minus 1 by dy by dx, isn't it? Dy by dx at the specified point, that is theta equals to pi by 4. Now all of you know this is minus 1. Now this value has turned out to be minus 1. So simplify this, your answer turns out to be exactly 1. So the slope of the normal to the given curve is how much? It is exactly 1. Okay, pause the video and note down the solution. Let's move to the next question. So next question is try to understand what the question is saying. Find the slopes of the tangent at 3 points where the curve cuts the x-axis. Okay, so try to understand what is happening here. So this is some random curve. Okay, I don't know how does it look, somewhat like this, let's say. Okay, and let's say this is your x-axis. Now see, this curve cuts this x-axis at different points. Okay, one is this point, one is this point, one is this point, one is this point. Okay, but here what you need to do is you have to find at the 3 points. Okay, for example, this is the point, so you have to find slope of the tangent at this point, slope of the tangent at this point, slope of the tangent at this point. This is what the question is asking you to do. Okay, this is the rough diagram. Just for the explanation's sake, I have drawn this diagram. Okay, now one more thing. Exactly on the x-axis, you know that the value of y will always be equals to 0, isn't it? So basically what am I going to do is I'll take y equals to 0. Okay, and I'll solve the equation that I get, and from there I'll find out the different points. Is that clear? Okay, so let me use this. So first and foremost, the given curve is y equals to x into x squared minus 3x minus 4. Okay, so call this as equation number 1. Now since you need to find the derivative, it's better that you open the bracket. So you get y equals to x cube minus 3x square minus 4x. Okay, so differentiating both sides with respect to x. So let's see how much do we get. So you get here dy by dx. Okay, so dy by dx is equals to, so you get 3x square minus this becomes 6x minus this becomes 4. So this is the derivative. Okay, you have to keep this thing aside for now because we need to find the different points at which the curve cuts the x-axis. Okay, so as the curve 1 cuts the x-axis, therefore your y must be equals to 0. As I said, on the x-axis the value of y will be 0, but you know the value of y is how much? Value of y is this much, right? This is x into x square minus 3x minus 4 equals to 0, right? So this is from 1. Okay, I've used equation number 1 here. In place of y I've written this much. Now all of you know, okay, so if you factorize this, how much do you get? You get x minus 4 into x plus 1. If you factorize this, you get x minus 4 into x plus 1. Okay, so this is equals to 0. So what does this mean? This means that either x equals to 0, x equals to 0, or x minus 4 equals to 0, or x plus 1 equals to 0. Okay, so that means I got the three values for x. Okay, so let's see what are those three values. So therefore x is equals to, first one is 0, next one is, from here you get 4, okay, and the next one is minus 1. Okay, so since they are talking about the 3 points, the 3 points are 0 comma 0, 4 comma 0, and minus 1 comma 0. So I got the 3 points. Okay, so therefore question is asking you to find the slope of the tangents at those 3 points. Okay, so therefore the first slope, okay, so dy by dx at x equals to 0. So this is going to be equals to, so dy by dx, look at this. So if you call this as 2, equation number 2, therefore from 2 you can say, from 2 dy by dx at x equals to 0 will be equals to 3 into 0 square minus 6 into 0 minus 4. So this turns out to be minus 4. So this is one of my answer. Another answer, so the slope dy by dx at x equals to 4. Okay, so this is going to be 3 into 4 square minus 6 into 4, okay, minus 4. Okay, so altogether if you calculate this, this is going to turn to be, so 3 into 16 minus 24 minus 4. So this turns out to be exactly 20. Okay, this turns out to be exactly 20. So the last one is, we need to find the slope dy by dx at the point x equals to minus 1. Okay, so let's see how much do we get. So 3 into minus 1 square minus 6 into minus 1 minus 4. Okay, so when you simplify this, this is 3, so this is going to be plus 6, which is 9. So 9 minus 4 is 5. Okay, so that means the slope of the tangents at 3 different points on the curve are turning out to be minus 4, 20, and 5 for you. Okay, so you may pause the video and note down your solution. Let's move to question number 9. Let's see what does this say. Show that the tangents to the curve y equals to this one at the points x equals to 2 and x equals to minus 2 are parallel. Very simple question. So the given curve is, the given curve is y equals to 7x cube plus 11. Okay, so obviously differentiate this. So differentiating both sides with respect to x will give you dy by dx is equals to 21x square. Okay, now you have to find slopes at x equals to 2 and x equals to minus 2. That will give you slopes of two different tangents, and if the slopes turns out to be same, then obviously the tangents will be parallel, because you know that for two parallel lines slopes will be equal, isn't it? Okay, so therefore your dy by dx at x equals to 2 will turn out to be 21 into 2 square. Okay, so 2 square is 4, so 4 ones are 4, 4 twos are 8, so it turns out to be 84. Now similarly dy by dx at x equals to minus 2 turns out to be 21 into x square, that is minus 2 square. Now minus 2 square is plus, right? So 2 square is 4, so 4 into 21 is 84. Now look at this, the slopes turns out to be same, isn't it? So since the slopes are equal, the tangents at x equals to 2 and x equals to minus 2 are parallel. Okay, so this thing you need to understand, right? So pause the video and note down the solution. Let's move to next question now. So question 10 says, if the tangent to the curve y equals to x cubed, so this is given to us, at 1 comma minus 6 is parallel to the line, this one, find the value of a and b. Okay, so understand the situation. The tangent to this at this point is parallel to this one. So can you say that the slope of the tangent will be equal to slope of this line? Obviously, right? So what am I going to do is, so let me first write down what is the given curve. The given curve is y equals to x cube plus ax plus b. Okay, and call this as equation number 1. So differentiating 1 with respect to x, let's see what do we get. So we get dy by dx is equals to, so this becomes 3x squared plus a. So b is a constant, so it will vanish. Okay, now we need to find the slope of the tangent at this point, isn't it? So therefore we have dy by dx at the given point. The given point is 1 comma minus 6. So the value of x is 1, y is minus 6. We don't have y here, so we'll substitute the value of only x. So it is 1 square plus a. So this turns out to be how much? It turns out to be 3 plus a. So this is the slope of the tangent. Okay, now the given line is, this is the given line, isn't it? So the given line is 2x minus 2y plus 7 equals to 0. Okay, its slope. Okay, so therefore slope of the line, let's say slope of the line, you can call this to be equation 2. Okay, so slope of the line 2 is equal to, so you know this is in the general form, so that's why it's going to be minus a by b. A is 2, b is minus 2. So this turns out to be exactly 1. Okay, now as the tangents, okay, so as the tangent and 2, that is this line, are parallel, so if they are parallel, their slopes are going to be equal, isn't it? So therefore, so you will do rest of the work out here. So therefore the slope of the tangent, that is 3 plus a, must be equal to the slope of the line, which is 1. Okay, so from here the value of a turns out to be 1 minus 3, which is minus 2. So I got the value of a. Okay, now I need to find the value of b. Now how to do that? Now for that I'll make use of this condition. It is given that 1 comma minus 6 is exactly on the curve. Okay, so that's why this must satisfy the equation. Okay, so as 1 comma minus 6 lies on this equation 1, okay, so we have, in place of y I'm going to write 1, and in place of y I'm going to write minus 6, and in place of x I'm going to write 1. So you get y, that's minus 6, is equals to x. In place of x I'll write 1, so 1 cube plus a is minus 2. Okay, x is also 1 plus b, we don't know what is b, so let's calculate b from here. So this is minus 6, this is 1 cube is 1, minus 2 plus b, so this turns out to be minus 6 equals to minus 1 plus b. So from here b turns out to be minus 6, so bring it out here, you get plus 1 equals to minus 5. So therefore the value of a is minus 2 and the value of b is minus 5. So these are your answer for this particular question. Okay, so pause the video and note down the solution. Okay, let's look at this particular question. So here your question says, find the points on the curve x square by 4 plus y square by 25 equals to 1 at which tangents are parallel to x-axis. Okay, so tangents are parallel to x-axis. Let's see how to do this. And next part is tangents are parallel to y-axis. Okay, so the given curve is x square by 4 plus y square by 25 is equals to 1. Let's differentiate this. Okay, call this as equation 1. So differentiating 1 with respect to x, so you get, okay, so 1 by 4 is a constant, so differentiate x square, you get 2x. Similarly 1 by 25, keep it as it is, differentiate y square, you get 2y dy by dx is equal to, differentiation of 1 is 0. Okay, so a few things are getting cancelled. For example, okay, so we'll do one thing. I will first find dy by dx. Okay, so first we have to take this out here. Okay, so this becomes x by 2 minus x by 2, in fact. So this is minus x by 2. Now this is 2y by 25 out here, 2y by 25. So bring this 25 out here and 2y to the denominator. Okay, so you get how much? Minus 25x by 4y. So this is the value of your derivative. Now see here, question saying, okay, so you need to find the point, isn't it? You need to find the point on the x-axis, remember. Okay, no, you have to find the point on this curve at which tangents are parallel to x-axis. Okay, so let me take that point to be x1, y1. x1, y1 is that particular point. So we'll find the slope of the tangent, that is dy by dx, at that point. So therefore your dy by dx at the point x1, y1 turns out to be minus 25 x1 by 4 y1. Okay, now number A. Okay, so as the tangents are parallel to x-axis, isn't it? So it is parallel to x-axis. Now tell me, what is the slope of x-axis? Slope of x-axis will always be equals to 0. Please remember that. Okay, so therefore slope of the tangent, that is minus 25 x1 by 4 y1, must be equals to how much? Must be equals to 0, because this is the slope of the tangent and this is the slope of the x-axis. Okay, so from here what you get is, you get x1 is equals to 0. Okay, so from 1, so you have x1 equals to 0. Okay, so what you're going to do is, you'll write x1 squared by 4 plus y1 squared by 25 is equals to 1. Now why am I writing this? Because x1 and y1 exactly lies on the curve. Okay, so x1 is 0, so it is 0 squared by 4 plus y1 squared by 25 is equals to 1. So from here, this is 0, so y1 squared turns out to be 25. So from here y1 turns out to be plus minus 5, because square root of 25, no, so you get plus minus 5. So therefore the required points are, okay, so one is x1, that is 0 comma 5, and other one is 0 comma minus 5. So these are the required points. Okay, so I got my answer for the first case. Now for the second case, you will do by yourself. I'll just say one thing. So slope of the line parallel to y-axis will always be infinity. How much is that? It is infinity. Now in infinity case, what you need to do is, okay, so your slope is going to be minus 25 x1 by 4 y1 is going to be infinity. So in place of infinity, what you can do is, you can write 1 by 0. Now reverse this, you get okay, so if you do cross multiplication, what you are going to get is 4y1 is equals to 0. So in that case y1 becomes 0, and similarly substitute out here, you get the value of x1, you get two values for x1, and you can find the two specified points. Okay, so pause the video and note down your solution. Okay, so we'll take last problem for today. So here question says, find the points on the curve y equals to x. Okay, so this is the curve, at which tangents are parallel to the line, this one. So shall I do this, or you will do by yourself? Okay, so I'll just write down the slope of this line. Okay, so the given line is okay, so write in general form. So minus 2x plus y plus 3 equals to 0. Okay, so therefore its slope will be equals to minus a by b. A is minus 2, b is 1, so slope is 2. So basically question is asking you find the points on this curve at which the slope of the tangent will be exactly 2. Okay, so kindly complete the sum by yourself. Okay, so today we'll be doing only this much. Thank you very much.